have been some significant changes in Section 4, Conductors. We'll go through it in several parts.
Some of the changes in Section 4 have seen a complete rewrite of Rule 4-006, temperature termination ratings, and the underground installation tables being moved from Appendix B to Appendix D. Existing tables 1, 2, 3, and 4 have been expanded to include all unshielded conductors rated up to 5 kV. The new underground installation configurations and correlated ampacity tables have also seen the addition of rated cables from 5 to 46 kV. Tables 1 through 4 have been expanded to include allowable ampacities for not more than 3 copper conductors rated not more than 5,000 volts and unshielded in a raceway or cable based on an ambient temperature of 30 degrees C. In Table 2, the allowable ampacity of number 14 and number 12 copper conductors rated at 60 degrees C have been lowered to 15 amps and 20 amps respectively. The ampacities in the 200 degrees C column have also been changed. In the 2012 code, underground installations were based upon tables located in Appendix B and Appendix D and were divided into continuous and non-continuous loads. In the 2015 code, underground installation configurations in Appendix B were relocated to Appendix D and were correlated with streamlined ampacity tables. Rule 4-004-1D applies to underground runs where the size of the conductors are 1/0 or larger. The rule has also been rewritten to include unshielded cables rated up to 5 kV, corresponding with tables 1 through 4. This installation diagram and corresponding ampacity tables are used when 3 or 4 conductor cable is direct buried. In Appendix D, the underground installation diagrams are immediately followed by the applicable ampacity tables. These tables provide the allowable ampacity for 90 degrees C conductors. When connected to equipment marked with a TTR of 75 degrees C, further derating calculations as indicated in the table notes are required. It's important to read the notes following each table. Note 1 of each ampacity table describes one of the types of installations the 90 degrees C rated conductors apply to. Note 2 of each ampacity table provides a derating factor of 0.886 to apply when the maximum conductor termination temperature rating is required to be 75 degrees C. Note 3 advises the user to refer to Rule 4-006 for temperature termination requirements. The Appendix B note to 4-004 must also be considered. The Appendix B notes to Rule 4-004 provide further information regarding the correct diagram and ampacity tables. Since the neutral current in a balanced system carries little load, it is not counted as a current-carrying conductor. Installation diagrams do not show the neutral, only the 3-phase conductors. Diagrams 10 and 11 are used for the most common underground applications. Appendix B also informs the user that the installation configuration diagrams may be applied to a single and multi-conductor cable as well as underground raceway installations.
If the underground installation is not in compliance with Appendix D, then a professional engineer will be required to perform the calculations. Depth, spacing, ambient temperature, loading, and other factors all affect the allowable ampacity of underground conductors. Rule 4-004-1F permits the ampacity of a conductor smaller than 1/0 and run underground to be selected using either Table 2 for copper or Table 4 for aluminum. Alternatively, the IEEE 835 calculation method can be used. The 2015 code has introduced ampacity tables for installations where shielded cables rated 5 kV to 46 kV are used. The installation configurations are found in Appendix D under the title of D17 Series and the accompanying Table D17 Conditions of Use. Table D17 outlines the requirements used to determine the ampacity tables in D17A to D17N. As shown, there are numerous parameters by which a professional engineer must perform these calculations. These new configuration illustrations define the installation methods. The changes discussed about copper conductors in Subrule 1 also apply to aluminum conductors in Subrule 2.
The ampacity assigned or calculated for a given conductor is the maximum ampacity. a lesser ampacity may be assigned to that conductor. 4004-1F allows conductors sized smaller than 1/0 and installed underground to have an ampacity based on tables 2 or 4, based on the marked termination temperature rating. The ampacity of conductors sized smaller than 1/0 remain the same for the underground and above ground portions of the run. A voltage drop calculation should always be done to confirm the size selected will comply with Rule 8.102. The underground portion must be installed to the minimum depth requirements of Table 53. Since the allowable above ground and underground ampacities are the same, there are no transition length restrictions in the run. There may be voltage drop considerations. In this example, we require an aluminum conductor rated for 60 amps. Note, the 60 amp panel has a TTR of 75 degrees. Table 4 lists number 4 AWG as having an ampacity of 65 amps in the 75 degree column. Alternatively, we can use the IEEE method. A voltage drop check determined that there was only a 1.9% voltage drop. The depth must meet Table 53 requirements. If you use the IEEE method, Table 53 does not apply. The length of the run cannot exceed the voltage drop requirements. To supply an alternative to providing IEEE 835 calculations each time an underground installation 1/0 or larger is installed, the method described in point 3 above may be used, subject to the acceptance of the authority having jurisdiction. The installation must comply with the diagrams in Appendix D. Table 53 cannot be used as the minimum burial depth, as Table 53 does not address conductor ampacities. The ampacity values in Tables 2 or 4 must be compared to the corresponding Appendix D ampacity table, and the lesser of the values must be used, subject to Subrule 4004, Subrules 17 and 18. The conductor insulation temperature rating and the column from which the conductor size is selected must correspond with the TTR markings in the circuit. Installations which are not installed to the requirements in the Appendix D diagrams must have ampacity calculations performed by a qualified person using the IEEE 835 method. That's it for Part 1. Please move to Part 2.